All right, get ready to dive deep, everybody, because today we're looking at a paper that has the AI world buzzing. It's a DeepSeek paper all about something called native sparse attention, NSA. And it might just be a big step toward AGI.
Yeah, this paper really takes on a big problem in AI development.
Long context modeling.
Okay, so what is that and why should our listeners care?
Well, imagine trying to understand a whole code repository.
Wow.
We're following a complex argument, but it's like across several documents. For AI, right now, processing all that information is just incredibly slow.
Yeah.
And resource intensive.
Yeah, it's like trying to read a giant textbook and remember every single detail, right? No wonder AI has problems with that.
Exactly. Standard models use what are called attention mechanisms to focus on certain parts of the data. But as the data gets longer, these mechanisms get really inefficient.
Okay, so how does NSA change things?
Well, it uses this idea of sparsity, which basically means it focuses on only the most relevant information. Kind of like when you're reading a news article.
You don't pay attention to every word, right? You scan for the sentences, the paragraphs that are important.
Right. We do that naturally all the time as humans.
Exactly. And that's what NSA aims to replicate in AI, being more selective to improve efficiency and understanding. Now, previous attempts to create sparse attention, they've had problems.
Okay.
A lot of them just focused on inference.
So making AI faster at using what it's already learned, but not faster at learning.
Exactly. And some weren't compatible with newer architectures, like graph query attention or GQA, which focuses on the relationships in the data, and multi-query attention, or MQA, which uses multiple attention heads to do things in parallel.
So it's like the old methods were a square peg trying to fit in a round hole.
Precisely. And this is where DeepSeek's NSA really stands out. It tackles these issues head on.
Okay, color me intrigued. So how does NSA actually work? What makes it different?
Well, it's designed from the ground up to be hardware aligned, which means it works super efficiently with the way that modern GPUs process information. Specifically, it takes advantage of these special processing units called tensor cores.
So it's kind of like optimizing for speed reading at the hardware level?
Yes. And it's also training aware, meaning it's built to learn how to focus on the right information during the learning process itself.
So it's not just a quick fix. It's actually baked into the way the AI learns and understands.
Right. It becomes a core part of the model.
Really interesting. Okay, so now let's get into the nuts and bolts. How does this all work?
Think of it in 3 parts: token compression, token selection, and a sliding window.
Okay.
So first, token compression. It's like making a summary of a long text. NSA groups chunks of information together to get the big picture.
Like reading the chapter titles of a book before diving in.
Exactly. Then you have token selection. Within those summaries, NSA picks out the individual bits of information that matter the most, kind of like highlighting the key sentences.
It's being very strategic about where it focuses its attention.
Right. No wasted effort. And finally, you have the sliding window. This is basically like short-term memory. It keeps track of the most recent information to keep everything in context.
Makes sense. So it's like remembering what you just read to make sure the story still makes sense.
Okay.
I'm starting to see how the pieces fit together. But the big question is, does it actually work?
And that's what we'll dive into in part 2. We'll look at the results and see if NSA lives up to the hype.
All right, so we've talked about what native sparse attention is, but does it actually work?
So the results are actually pretty amazing. The DeepSeek researchers, they trained a massive AI model, 27 billion parameters, using NSA. And it did just as well as traditional models on the standard benchmarks, even for like short texts.
Oh, so it's not just good for long stuff. It works for the short stuff too.
Right. But where it really shines is with tasks that need a deep understanding of that long context, like answering questions across multiple documents or understanding a giant chunk of code.
Right.
They even tested it on this like needle in a haystack challenge, finding a specific bit of information in a huge data set.
And did it work? Did it find the needle?
It did, with the perfect accuracy, even when they made it search through 64,000 words.
Wow.
Which really highlights just how efficient NSA is.
That's incredible. It's like finding a specific grain of sand on an entire beach.
Yeah, and it's not just about finding information either. They also tested NSA on these complex reasoning tasks, like solving math problems that take multiple steps.
Oh, so we're not just talking about a glorified search engine. This thing can actually think through problems.
Exactly. And on those tests, It blew the traditional models out of the water, especially when the problems needed longer chains of reasoning. And that's where we start to see that potential for AGI.
Okay, let's address the elephant in the room then. We started this deep dive talking about how NSA could be a stepping stone to AGI. Is that really possible?
Well, it's certainly a step in the right direction. I mean, think about it. One of the biggest hurdles for AGI has been the ability for AI to just process and understand the sheer amount of information that we do as humans.
Right, it's like we're constantly drawing on, I don't know, a lifetime of experiences, countless books.
Right.
The entire internet.
Yeah, and traditional models they haven't been able to handle that efficiently. But NSA, with that ability to focus on only what's important, it offers a way to get over that limitation.
It's like giving AI a brain that can handle information overload without even breaking a sweat.
Right, and that's huge for AGI. I mean, if AI can efficiently get to and understand these vast stores of knowledge, well, who knows what kind of cognitive abilities they might develop.
That's true. But I mean, wouldn't we need more than just information processing for AGI? What about things like consciousness, creativity, even common sense?
You're absolutely right. NSA is just one piece of the puzzle. You know, we still need a much deeper understanding of just how human intelligence works at a fundamental level.
It's like we're trying to reverse engineer the most complex structure in the known universe, the human brain.
It's a tough problem, but I don't think it's impossible. You know, just like NSA has shown us a path to more efficient information processing, there are other breakthroughs happening in things like reinforcement learning, neuro-inspired computing.
So it's a multi-pronged attack.
Exactly. We're tackling this problem from all angles, and NSI is a big part of that.
Okay. Well, this is all very exciting, but let's bring it back down to earth for a second. Why should our listeners care? How does NSA and this whole AGI thing affect them?
That's a great question. While, AGI might feel like some distant thing, the technologies being developed to get us there, they're already impacting our world.
Right. Like, what are some examples?
Well, think about those AI assistants. The ones that can actually understand your needs and even, anticipate what you're going to ask.
Right.
Or personalized education systems. Imagine a system that tailors itself to each student's learning style. Or medical diagnosis tools that can look at a scan and spot a tiny tumor. NSA and similar advances are making AI more intuitive, more personalized, more powerful.
It's really integrating it into our lives.
Yeah, and this is just the beginning.
All right, I'm getting on the hype train with you.
Good.
But let's shift gears a little bit. Talk about where NSA fits in the grand scheme of AI research. I mean, we've mentioned AGI a few times, but how does it fit into everything else going on?
Well, I think it represents a huge step toward creating more powerful and efficient AI, unlocking potential that we just couldn't even touch before. We're put through the boundaries of what we thought possible.
We're on the right track, even if we don't know exactly where we're going.
Exactly. I mean, that's what scientific exploration is all about, right? Asking those big questions, pushing the limits of knowledge, and embracing the unknown.
Okay, I like that. Now, we've covered a lot. From the technical details of NSA to the potential applications, even the ethical concerns. But there's still one question we haven't fully addressed. Could NSA really be the key to unlocking AGI?
And that's where we'll pick up in the final part of our deep dive. Join us as we explore the path from NSA to AGI and what it all means for the future.
Welcome back to the deep dive. We've been talking all about native sparse attention and how it could change the game for AI. Now it's time for the ultimate question. Could NSA actually be the key to unlocking AGI?
You know, that question has everyone in the AI world buzzing right now. AGI, the idea of a machine that can actually think like a human, has been the holy grail of AI research for so long.
Yeah, it's like science fiction come to life.
Yeah.
A machine that can learn and reason and solve problems just like us.
Right. And NSA might not single-handedly get us to AGI, but it could be like a crucial piece of the puzzle.
Okay, so how does it get us closer?
Well, one of the biggest roadblocks to AGI has been the amount of information you need. I mean, humans, we learn from a lifetime of experiences.
Right.
Countless books, the entire internet, and traditional AI models, they just can't handle that much data.
It's like trying to download the whole internet using dial-up.
Yeah, exactly. But NSA, with its ability to only pay attention to what's important, it gives us a way to overcome that. It lets AI process all that information without getting bogged down.
So it's like AI with a brain that can just handle information overload without even blinking.
Exactly, and that's huge. If AI can actually access and use all that knowledge, well, who knows what it could be capable of?
That's true. But wouldn't you need more than just information processing for real AGI? I mean, what about things like consciousness or creativity?
Yeah. You're absolutely right. NSA is just one piece. We need to really understand how human intelligence works, at the deepest level.
Right.
We need to figure out how to put things like intuition, imagination, even emotions into a machine.
We're talking about reverse engineering the human brain. I mean, that's the most complex thing we know of.
It's a huge challenge, but look, just like NSA showed us a new way to process information, there are other breakthroughs happening in reinforcement learning, neuro-inspired computing.
So we're attacking the problem on multiple fronts.
Exactly. It's a multi-pronged attack, and NSA is a critical part of the strategy.
I like it. Okay, this has been fascinating, but let's bring it back to our listeners. Why should they care about any of this?
Well, AGI might seem like a far-off thing, but the tech we're building to get there, it's already having an impact.
Like what? Give us some examples.
Okay, well, those AI assistants.
Yeah.
The ones that can understand what you need and even anticipate what you're going to ask.
Right.
Or imagine personalized education systems that are tailored to how each student learns best. Or medical tools that can spot a tiny tumor on a scan that a doctor might miss. All of these advancements are happening because of things like NSA.
It's all coming together.
It is. It's making AI more intuitive, more powerful. It's weaving it into our lives.
This has been an awesome journey. We've talked about it a lot. But before we wrap up, I want to leave our listeners with something to think about. We've talked about AI learning from tons of data. But what about the data it creates itself?
That's a really interesting question. Could we use NSA to let AI learn from its own experiences, its own successes and failures?
Right. I mean, could that lead to a kind of intelligence that's constantly evolving and improving on its own? I guess we'll save that question for another deep dive.
Yeah. But for now, we've come to the end of our exploration of native sparse attention.
We've gone from the technical details to the big picture implications. I think it's safe to say that NSA is a game changer. It has the potential to reshape the future of AI as we know it.
Absolutely. And this is just the beginning. There's so much more to explore, so much more to learn in this exciting field. So keep questioning, keep digging, keep pushing the boundaries.
So until next time, keep on deep diving.